Hi everyone, you are watching Biology with Inshara, and in today's video we are going to talk about the topic diffusion. Now before we get deeper into this topic, let us first understand the meaning of the word diffusion. Now the word diffusion means it is the net movement of molecules, ions or substances or even particles from a region of higher concentration to a region of lower concentration, that is down the concentration gradient. Now what does the word net mean? Now this is the perfect definition of the word diffusion, and I'll explain why. Always include the word net when you're writing the definition of diffusion, because net means all together, and this basically implies that the molecules are moving, all the molecules are moving together from a region of higher concentration to a region of lower concentration. Now what is concentration? Concentration is the it means how close the particles are in a specific region. Like if there are more number of particles in region A, then we say the concentration is more. But if there are less number of particles in region B, then we say that the concentration is lower there. Therefore, diffusion should occur from A to B. And that's exactly what concentration gradient means. It is the difference in the concentration between two regions. As explained earlier, A has a higher concentration and B has a lower concentration because B contains less number of particles and A contains more number of particles because they are closer to one another. Now, one other key point to understand is that diffusion does not require a membrane. It can happen without a living membrane or without a partially or selectively permeable membrane. It does not require anything. It can occur even in mid-air. Now we'll get to that. I'll be giving examples as to how diffusion can happen in the air. Let us first understand this graph. So this is a graph about the concentration gradient, which basically means the difference in the concentration between two regions. Now, if you look at the graph, you can see that there's region A and then there's region B. Region A is at the top and region B is at the bottom, as you can see on the graph. And we can see that in the y-axis of the graph, A has a greater concentration and B has a lower concentration, because we know that the higher the number, the more the concentration, or the more the number of particles, the higher the concentration, and the lower the number of particles or the lower the number, the lower the concentration. And so therefore, according to the definition of the word diffusion, diffusion should occur from A to B, from 30 to 10, from the region of higher concentration to the region of lower concentration. And you can see that the graph is going down. So we say that diffusion happens down the concentration gradient, and that's exactly what it means in definition. When we say down the concentration gradient, we mean from higher to lower. Now, it's always a good idea to include all those words that I just spoke about. For example, having the word concentration gradient and having the word net, which means all together, because this creates a good impression when you write like this in your exam, because it implies that your concepts are clear. Moving on, we will now be discussing examples. First of all, let's first understand that diffusion can only happen in liquids and gases, which are collectively called fluids, which means state of matter in which the particles can move about. And you know that particles can only move about in liquids and gases, and they are fixed in solids. So we can say that diffusion only occurs in fluids, which is gas and liquid, as their respective molecules can move about each other and therefore spread. Now, diffusion can never happen in a solid, as their particles are fixed in their position and they do not move, so diffusion is not possible in this case. Let's first consider the examples in a gas: the smell of perfume or the smell of cooking or food. Now when you spray perfume in one region of your room, then the smell of the perfume spreads to the other corner of the room, and that's because of diffusion. The air particles constantly collide with one another, and they help in spreading the smell of the perfume from the region of the higher concentration to the region of the lower concentration. And same goes when your mom or when your dad is cooking in the kitchen. So when they cook, the food of the smell over there is at its highest concentration, and they spread to areas of lower concentration, and that is in your room when you are able to smell their cooking. Note that when diffusion happens in gases, they happen with the help of the air particles that surround you, as they constantly collide with one another, and they help in the spreading of the other molecules from the higher region to the lower region. Now, in the next slide, which I'm sure you can see right now in front of you, gives the examples of diffusions that occur in liquids. Now, diffusion happens in miscible liquids. Now, the word miscible means two liquids that can mix with one another. Now, when I say immiscible, I mean that two liquids that do not mix with one another. For example, try mixing oil and water. They never mix, and they are examples of immiscible liquids. Okay, and if you read again, you will see that I've written down that when you add food coloring to a solvent, now they are miscible liquids, because when you add food coloring, you're basically mixing. The food coloring is diffusing in the solvent. It's spreading, and when you mix two different colors of paint, then again they both are mixing, and so we can say that diffusion is happening, and it basically happens same as we discussed in the explanation of gases. Now, if you look at the picture, you can see that we're adding potassium. There's water, and then there's potassium manganate, and we're adding potassium manganate in water from the dropper. As we add the potassium manganate, you can see that it starts to mix, which means it is diffusing from its region of higher concentration to its region of lower concentration. Eventually, it is evenly mixed as it has reached its state of equilibrium, and this happens in all cases of diffusion. When you mix two certain different things, they will mix. However, at the very end, they will reach a state of equilibrium, which means the solvent or the gas has evenly mixed. And that's why in the case here, you can see that after mixing potassium manganate, it is now fully purple, which means it has evenly spread out, and diffusion has also occurred. Let us now discuss the factors that increase the rate of diffusion. The first one would be temperature. Now, when you increase the temperature, you're basically giving more energy to the particles, and you're basically giving them more kinetic energy, which means you're giving them more energy. And when they have more energy, they move faster, and therefore they will spread or diffuse faster. And the second factor, or that would increase the rate of diffusion, would be concentration gradient. When the distance is greater between the two regions, then the particles will travel faster, and therefore we have successfully increased the rate of diffusion. Suppose there's region A and then there's region B, and the distance between the two regions is higher. And when we say the distance is higher or greater, the rate of diffusion will also be greater. We can also increase the rate of diffusion by increasing the concentration of particles or molecules in one specific region and drastically decreasing the concentration in the other region, so that it can successfully happen from the top region to the lower region. Okay? And the last one is the MR, also known as the molecular mass, which is actually a measure of how much do atoms weigh. Okay? So the lower the molecules weigh, which means the lighter they are, the faster they can move or travel. Just think of it as like this: if your atom weighs lighter, then that atom will be able to travel faster. Like if you weigh a lot and the other person weighs less, then the person who weighs less will be able to travel faster. Similarly, in the case here, when the MR or the molecular mass is lower, which is different for every atom on the periodic table, the atom or the molecules altogether will be able to travel faster, and the rate of diffusion will happen faster. If you decrease those factors that I have just explained, then the rate of diffusion will decrease. Now, thank you very much for watching this video. I really hope you guys enjoyed and you learned a lot from this video. Do like, follow, share, and subscribe, whether you're watching this on Facebook or if you're watching this on YouTube. And as always, keep learning, and see you next week.